So thank you for staying on. This is going to be the best session of the day. What we're going to try and do in this session is we're going to talk about these experts here are going to give you some input on how to create intelligence from existing and upcoming data sources. And they're also going to give actionable advice, so pragmatic advice that can help startups based on some of their own lessons. So I'm going to introduce myself before I hand over to the others. I work for an organization called the Group on Earth Observations. And we're one of the biggest well-kept secrets in the industry. We are an intergovernmental organization that works on behalf of 104 national governments. So actually, that's significantly more in terms of organization. It's hundreds of organizations around the world who want to provide advocacy for Earth observations. So I get paid to do this. I get paid to travel around and talk about how great Earth observations are. But for us, Earth observations are anything in, on, around the Earth. So we're also doing in situ sensors, airborne sensors, as well as satellite imagery. And we run a portal called, if you go to geoportal.org, there are 200 million open data sets in there. 200 million that have been built over the years. So we broker private sector data in there as well. So there's a mix of Earth observation data. So it's very good for startups because it's all free and accessible. You can go in and pull it from there. So my name is Stephen, and I'm a Scotsman living in France. And there's a reason I'm saying that. I'd like each of the presenters to give your name, your organization, what you do, where you're from, and where you live. That's 5 things. Come on, you guys are rocket scientists. You must be able to remember that.
Oh, we'll do my best. Right, so my name is Rafal, and I'm one of the co-founders and the CEO of a company called ICEYE. We do micro-synthetic aperture radar satellites, and I'm a Pole originally, living in Helsinki, and the company is also based there.
Thank you.
Hello, I'm Julien. I'm co-founder and CEO of VEOWARE Space, one of the newcomer in the very high-resolution imagery, willing to decrease the price of such a valuable assets, because we're going to talk about it, how to extract value out of those pixels. And our company is based in the UK, and I am living in Belgium at this moment.
Pascal. Pascal is my name. I'm currently living in Barcelona, working with Telefonica Alpha and sort of Google X inspired moonshot factory. But I'm building, or have been building, my company called Eyve. We've been using, or are using, satellite data from different channels to detect diseases on fields using sort of early detection algorithms and time series processing algorithms that we've developed. And yeah, that's it.
And I'm Robbie Schingler. I'm co-founder and chief strategy officer of Planet. And Planet operates Earth observation spacecraft, and we collect the whole Earth every week right now. And then as 88 satellites get commissioned, we get the whole world every day. And we process that data and expose that to a web-based platform to allow for people to build applications on top of it. And I'm an American living in Holland.
Thank you. So I'll go to you first, since you talked about getting value from pixels. How do you think we move from imagery to intelligence? What's your perspective on that?
Right. I think, so we are in the Earth observation panel, and we couldn't, according to me, we couldn't talk about Earth observation without talking about resolution. There's things that you see, let's say, in a wide coverage, in, let's say, broad details, or a very, say, narrower picture, but still in very high resolution. And somehow I'll probably jump also to Robbie, because you probably have the other half of my answer. I think that we're heading towards a world where you have companies able to detect change on a daily basis, massively and globally, while you have other companies, maybe like mine, or the ones like Digital Globe, I know there are people in the room, that may be able to zoom in on those changes, and finally be able to extract the information more on, say, using their machines would have been trained to detect specific shapes and specific colors, maybe from the spectral bands. So my answer is probably combining the different actors' data and ability to detect change, contact the companies that are able to zoom in, and finally, maybe a third type of entity who is more focused on machine learning that are trained to identify what has been zoomed in.
So, Robbie, do you have a second part to the answer?
Well, I think to say it in to say it the same thing slightly differently is that there's multiple data sets I think that are necessary in order to really extract insight. And this is all due to the fact that we are going through a sensor revolution on the Earth, and we're beginning to bring it into space. And what that means is we're just collecting a whole bunch of data, like a whole bunch of data. And storage and compute has become commoditized. So you can buy it just like you're buying electricity. And then that, again, decreases the amount of money necessary in order to do something interesting. So when you combined storage and compute with a whole bunch of near real-time information feeds, either collected from overhead or on the ground, then that's when you can put some good algorithms toward it in order to try to extract meaning. And if you can extract meaning autonomously, you can come up with new products that then work at the speed of business. The current state of where Earth observation is today primarily is driven, I would say about 80% or so, by a government end customer asking for a project. And the movement of what we're trying to do with Copernicus and with the Diaz platform that the European Commission is putting out with is to try to really stimulate this into being a product industry rather than project-based industry. And that is the data. It is the access to the data and the compute against it, but then it's also doing analytics against the different information feeds that are available.
So, Rafal, if we take this product industry concept further, how do you see that bringing more intelligence from the imagery?
How do I see bringing more intelligence from the imagery? Right, so I think there are a few steps necessary, and Robbie pointed it out well that we are going through the sensor revolution, and we've started by gathering large amounts of data. I think there are still few steps that we've got to take before we can reach the kind of moment when different verticals and different industries actually take advantage of this data. One is fusion between different companies. For sure, I agree that different types of assets and different type of data is necessary. Secondly, we would like to make sure that anyone has access to this data, and this data is accessible for a reasonable price. So actually, I always think that developers around the world will be able to use this data and create applications based on their vertical knowledge that they have. And I always think of this in a way that this partially is going to be on us as companies that build Earth observation satellites, and partially is going to be on someone that has the deep vertical knowledge that knows the problem that they are going to solve. So in our case, when we started building ICEYE and we were thinking of ice monitoring, there was one serious problem that we were solving, and that was basically how to optimize a route of a vessel that passes through ice. And when we thought about a division of roles between us as someone that is going to operate satellite and someone that's actually going to provide a product to companies like Maersk or ExxonMobil, we thought that we are going to acquire data. We will deliver this data to them through a cloud infrastructure. We are most probably going to perform the first processing step, which is going to derive what kind of ice and where this ice is located. But this is where it stops from our perspective. Then someone else that actually knows how to operate vessels and how ice influences vessels and how to make the best route of the information where and what kind of ice is going to take this further and actually create a product.
Could you just expand on ice, what AIS means?
Sure, of course. I mean, we can expand on ice and any other things. Like we can, when I look at what Orbital is doing with car counting, like I can understand myself how to derive where a car is from a picture. But I have to say that until I've heard about who do they sell this to, on how they are combining this information in order to create a product that hedge funds are further purchasing, I didn't have this insight into the financial industry in order to be able to make the move from where the cars are to what is actually the product that the hedge funds need. So I guess in our side, all these companies that are basically over here, what we would need to create is definitely join forces in order to allow all these data streams to be combined, make them easily available, and then do the first layer of processing that whenever someone is trying to actually create a product for a specific vertical, they don't need to have the in-depth knowledge about how this data is being captured and generated, but they can use already a certain set of information that's within it, which is what kind of objects do we have, where these objects are, and potentially how these objects are moving or whether they have changed their position since the last time we've captured that. And that would be my vision on how this should move forward in order for us to actually move away from the governmental customer being the key customer and actually utilize this revolution in sensors and observation for the better good.
Okay, I'll come back to a couple of your points. There was some talk about machine learning, Pascal. Can you, in layman's terms, talk a little bit about machine learning and moving towards intelligence from that perspective?
Yeah, I mean, we're talking about machine learning in the space sector. So what we're looking at is, I think, three main areas. Number one would be infrastructure itself. So if you're thinking of a satellite, there's not only imagery data and sensor data coming down, there's also sort of health data from the satellite coming down. So with this entire idea of, in Industry 4.0, as the people would talk about, there's this predictive maintenance idea, which in space also is really, really important. When you're thinking about ISS and these kinds of long-term missions, they don't go up there like every day, and it would be okay to figure out if a problem arises like the day it does. You have a huge advantage also in lifetime cycles for satellites, everything. If you can figure out that a problem may happen or the chances of problems happening, if you can sort of find patterns that indicate that something may be at risk before it actually happens. We do that on Earth, so on ground all the time with cars, trains, every single industry is moving in that area. Space will as well. Then there's sort of area number two would be image recognition. We're all familiar with that right now. When you take a picture with your iPhone, it will classify faces and then cluster all the images that belong to a certain face. You can go further if you plug an image into Google Image Search. It will give you similar images showing similar objects and tell you what is on that image. And that's all sort of old commoditized knowledge already. If you're thinking about what's happening in the labs right now, we're going through image queries. So I can ask a natural language question about an image, and then the algorithm will figure out what is on the image, what the relationships from objects are within the image, understand, quote, the language from the question, and then deliver a language answer to my question based on that image. So we're already there with end-to-end understanding and comprehension processes in machine learning or machine intelligence, however you want to call it, spaces. Obviously, that's a thing that gets me really excited about space, is this idea of if we have daily coverage of the entire world with high-resolution satellite imagery, I can start asking questions like how many. You touched on that from the hedge fund idea. How many cars are there on Walmart parking lots right now? The algorithm can take a look at the addresses of all the Walmart stores, for example, recognize the cars, count the cars, give me a percentage of the parking lots that are occupied, and I, as a hedge fund, could be able to predict the sales of Walmart. And that's already happening. You've already touched on that. And there's so many exciting opportunities in machine vision here as well. Third idea would be thinking of imagery as a video, more time series / video. When we're looking into daily satellite images, it's not anymore that I have to take a picture every week or every 2 weeks, 16 days, whatever the old satellite programs are delivering now. You can think of Earth imagery as a video, taking a picture of a certain place that you're interested in every day, you can really monitor changes. You can monitor movements of different things, movement of eyes, movement of or growth of crops, which is what we're interested in, and then actually start modeling time series and understand long, short, medium-term patterns in these time series, start predicting and finding anomalies within these time series across the entire world. And that's, I mean, there's the three main areas which I see as opportunities in the space Earth observation sector for machine learning. But I'm sure there's much more that you could talk about, but time.
Maybe also an opportunity, a question to you is, from my perspective, is that true that is there still a problem on training those machines? I mean, I've been amazed on seeing how you can recognize figures or even cats on Google Image, but that's because there's a billion cats on Google Image, right? And people love to put their name of their cat and they say it's a cat. So how do we move on getting that for Earth's imagery, which is somehow not so much, there's not a lot of image where people say, hey, that is my garden, or hey, that's this. How do we train those machines? Is there a way to do that for Earth observation?
I'll throw that back to the panelists. Robbie, do you have a perspective on it?
Yeah, so there are a lot of other data sets that are geo-referenced, whether it's cadastre data set or OpenStreetMap or other types of things. So we can take that open data, then use that as labeling and classification. You, of course, the challenge with machine learning over time is if you want to make it super reliable, you need to have an accuracy indicator associated with that. And then that becomes the thing that you always work on. Then that's going to be the differentiation. Right now, it's a bit easy to get started and super hard to do it really, really well. So yes, you do have to do classification, but there's a bunch of other data sets that are already out there that really make it easy to get started.
Yeah, if I can just jump on that question as well. So I think there's this idea of deep learning, which is out there, which comes to the classification point of if I have 1 billion photos of cats labeled, I will be able to learn through brute force learning the patterns, the statistical patterns that make up a cat, and then whenever I see a new picture of a cat, I will be able to tell with a certain likelihood that's a cat. Yeah. That's not the only idea of machine learning, right? There's unclassified methods or unlabeled methods where I would just need to, what I've talked about earlier, take a look at the time series or a billion pictures themselves and then learn the similarities without knowing what it is, and then be able to say, does this picture belong to that random group of the other billion pictures? And I don't need to be able to tell that's a cat, but I can tell to the end user, hey, this is an image that belongs to the class of these other images, tell me what it is. You start off with that, you go to a different, to a long circle of feedback from users, get information, have other people label your images, and then at a certain point in time, you will be able to have that asset as a data set that enables you to do classification that other people wouldn't be able to do because they don't have that data set. And then number 2 would be the idea of crowdsourcing of this information. So the Amazon Mechanical Turk is something that every university machine learning project likes to use. As you go out, pay tiny amounts of money to people to actually label images for you, and that's something that's already happening in the space industry as well. And then you just wait and spend a couple of percentages of your funding money on that, and then you're able to start the classification. So I don't see that as an entrance boundary. I think the much more exciting space is in the machine learning research side itself, is how can I minimize the number of pictures that I need to sustain the same accuracy that someone else needed much more pictures to classify. We're already there. People are talking about one-shot learning. So I see one image of a cat. I'm able to abstract the sort of edges and the abstract relationships that they have to each other from the cat. And then with my second picture, I'm already able to tell that's a cat and not a dog. Obviously, you don't get the accuracies of 99-point-something% that you would with classified images, but it's sometimes good enough to work.
So I'd like the audience to consider if you have any questions that you'd like to put around this moving towards intelligence. I'm going to ask the panelists another question, but if you have a question related to that, I'm going to give you a chance to ask that in a few minutes. So you talked about fusion between different types of data. What do you see as the challenges to doing that? What are the practical or pragmatic challenges in doing that? Rafal?
Revenue sharing? I guess it may be an interesting question from the financial perspective, how multiple companies are going to assess the value that a certain data stream brings into a globally or a fused data stream. So we would have to, in a way, we are all going to make our revenue based on the amount of data that consumers will use and they will use for their applications. And then we'll have to somehow assess the value that this particular set brought in. I mean, I don't think it's going to be a big problem. I guess there are a few problems related to logistics. I mean, definitely we just have to get to speak to each other and agree which platform are we going to use. Right now, as far as I know, everyone is building their own, which probably is not the best idea. Ultimately, this platform is also a source of revenue for you. So who is going to drop out their ideas? And I mean, the people have already spent money and did work on their platforms. Why should we choose one or the other? This is, of course, a question that's very interesting. Then there are, of course, questions from the technical perspective related to how well the data is going to be georeferenced, whether SAR, I mean, you can capture it regardless of weather condition or time of day, so you'll always have the consecutive frame, whereas with optical, you have to wait for cloud coverage. But I guess these are kind of technical issues that are going to be solved not by us, but by people that will analyze this data. So from the perspective, in order to make this next step that I kind of mentioned earlier, so in order to bring the diffused capabilities to developers around the world, I mean, I guess this is a little bit on us in a way to, after this panel, speak to each other and figure out how we can make this work together so that all the companies basically win on this deal rather than lose.
Thank you. Julien?
Yeah, the problem might be that, oh, maybe I'm challenging everyone here, but is it, we can't put, at least from my side, the name on a killer application. So if this killer application was named, we could sit together and say, hey, that's the one we should serve, and therefore we could decide early on to build one system that just diffuse all the data, and we would process those data accordingly to make it easy, like you said, for the end users to use directly, like, hey, ready to use, ready for you to, like, say, extract the value for your operational needs. But none of us, at least the people I talk to, can name this killer applications. We all want to know how many barrels leave Guahar to be able to expect the price of oil tomorrow. But you know, there's not yet at least a common effort to say, hey, we should serve this, and this is at least something which is going to be so much valuable in the future. So far, like you said, the better we talk until somebody has a genius idea and say, hey, that's where we should all go. And so far, we still build our own platforms, and as you said, somebody will have to lose eventually. I think the CEO of Earthcast made it, Wade Larson made a point very early on, I think it was 2 years ago, and he said, well, at the end, there's now 10 companies that wants to launch their own constellation. His bet was could remain only 3, and we see this move already happening where small companies get acquired, people get bigger, which is great. I mean, it makes a better choice for end users because eventually they only contact one person. But it's also good for the market on our side because when company gets acquired, investors can see an exit, so somehow that's also good. But let's say I'd come back to the killer app. Difficulty here is that we cannot build a fused data set for one applications only.
So either of you have anything to add in terms of platform or killer app or? No. So do we have any questions from the audience on gentleman over there?
I'm a CFO.
If you could just hang on for the...
Yes, I'm a CFO at Cloudeo. We actually build that platform. We have about 12 developers, and each have about 5 applications that are there. Our target is to go forward. My question to you, and I spoke with you offline, my question to you is, when you speak about the platform, which 5 qualities that platform would need to have for you to become attractive? Thank you.
So the question was, how many qualities? 5? Whatever. So which qualities does the platform need is the question. Robbie, yeah.
I think accessibility of the data, the performance, so speed. There's a concept of data gravity. So the more data close to one another, the better, because then you can fuse analytics across multiple data sources. I think that's where we are actually today with respect to the data platform, and then where things will go is more to platform services where people can subscribe to other people's derived information feeds that are coming from it, to then build more true context-aware applications that that abstract away GIS and just really get at information feeds that are associated with it. But there is a challenge. I didn't want to add to the latter because it is a business model challenge. Everyone's talking about commoditization of pixels, and that's probably because they don't own the pixels, because the business model today is still that. And moreover, if you are collecting imagery, you have to have a data processing capability internally in order to get the raw data to make it usable. So then you might as well spend a little bit more to go further down and make it more accessible and actionable for people. So we will have proliferation of platforms.
Do you want to add to that?
Yeah,
Pascal?
I like adding to what was already said. I like the idea of a toolbox where you will eventually have sort of like the AWS services. I like that analogy a lot. Having a machine learning framework, API, whatever, that you could just one line of code say which satellite imagery provider you want, what machine learning function you want to use on what geolocation image from what time, and then the output is the combined function of all of these input variables that you're getting. Something like that will make it more accessible to much more people than it is right now. Because when we're talking about accessing Earth imagery, especially for early stage startups, which is where I've got my experience from, you have the choice of either paying money for accessing imagery, and then it will be easier to access better quality and things like that, or you go for the governmental tax money paid data sets that are horribly complicated to access, not incredibly, and I don't want to step on anyone's feet, but not incredibly well documented and really scientifically purpose, which is good. I mean, that's what they were made for, but that's not what is really helpful for tech entrepreneurs of our generation. So I think this entire idea of making it like a plug-and-play toolbox with different services that integrate and all the qualities that were already mentioned, that will be the key to success in that area. Oh, and reliability, obviously, because we've seen that with AWS just a couple of weeks ago. Like, you don't want your servers to fail, because then 100 companies' infrastructure will just be dead. And that's not their fault, so you lose all the credibility, and then it's done.
Rafal?
Can I comment quickly? I will add a little bit. I think something that we would be looking for is popularity of your platform, and that's from both the people that put their data into the platform as from the user's perspective. I mean, anyone that's building this kind of cloud infrastructure and wishes for us to put data into this cloud infrastructure, they should just show us that this is the cloud infrastructure that's going to be used by all the developers around the world in 3 years, and we are going to be the first ones to put data on board. I mean, it's not a question to me. I'm not building this platform. It's probably a question to people that are building these platforms and to the users of these platforms. What makes the platform to be very easy to use from the developer perspective? And if you have this sorted out, then your platform will be the popular one, and you will be the one where everyone is going to host their data.
Okay, do we have another question from the audience? Anyone else have any queries on the intelligence aspect? So everybody's an expert on deep learning, machine learning. Great. Okay, so we're going to change a little bit to change tack and we're going to move on to the second area, which is about this actionable advice. When Robbie spoke earlier on his first panel, he talked about experience of teamwork and collaboration. So I'm going to give you a bye for this at the moment, Robbie. But what I'd quite like for the other three to say is, where are you at in your startup right now? How old is it? And what's your experience around teamwork? What experience and advice or lessons learned could you share? And I'm going to go to Pascal first. And you can talk about successes and failures.
Okay, so I'll start with the failures. We have had a really interesting journey from a 4-people founding team to 2, out of which only 1 was within the initial 4. And that has taught me a lot about, I liked what you said earlier, is that you have to love the people, even though it sounds cheesy, you have to love the people that you start this journey with, because it's going to be a rough ride, and there's going to be a lot of breaking each other's arguments and starting to hate each other, but then in the end you will need to find a solution and you will need to move forward quickly, because otherwise you're killing the business. And that would be my number 1 lesson learned is the team is the most important. Like every experienced venture capital investor will tell you that especially early stage, they're not really investing in ideas or platforms or customers or anything. They're investing in teams. So that's going to be the key point for you to figure out when you're starting a venture in that space, in any space, really. Is going to be find the right team, be complementary to each other. Don't have the same expertises. Don't try to have the same expertises, and get rid of the bubble bias. Sort of having the same view on everything. That's not a good ground for any discussion. You have to have different angles of views and different things like that. So that would be biggest mistake and biggest lesson learned. Number 2 would be build your prototype as quickly as you can and get user feedback as quickly as you can without spending a lot of time in your heads. I mean, we're talking about rocket science for some people in this room. We're talking about data science analytics for others, or platform building for others. These are really, really complicated challenges. But if you're not able to break them down in smaller problems that you can quickly test as hypotheses, then that's probably not the right path to pursue. So if you have to have a $200 million seed investment to build your first prototype to get any feedback on, then good luck. But if you're able to break it down in smaller challenges that you can quickly and rapidly evaluate and test, then that's doable. So I think that would be number 2 from my side.
Great. Julien?
So I'll try to also start with the failures. So
And can you please say like how many people are in your company, how old it is?
Yeah. Sorry. So VEOWARE Space, the UK company we've been around for 2 years, talking to customers, but we only needed to register the company last year. Somehow you can talk to customers without a company. That's super important. You don't need to have a business card, say, hey, I have a website. No, you just say, hey, what about this? You can get user feedback before. It's just one day say, hey, can we sign an NDA? Then you think twice. You say, well, maybe I don't want to go into jail. Maybe I need a limited company. So that's what we did.
And what's an NDA?
It's a non-disclosure agreement. So when you need to share confidential information, and usually an entrepreneur sees nothing confidential because they say, yeah, I can tell you more, but your customers sometimes say, I don't want to protect my secret. So you don't want to sign a confidential agreement on your own name. So that's why we registered the company to help them at least going through this. And therefore, we are 2 co-founders. We have support for different from our partners, mainly in engineering, as we look for buying the best satellite solution, and we include our secret sauce. And all vendors provide us with engineering support, about 2 engineers per company. We have a board of advisors. So my recommendation here, as I can jump on your question, is please get gray hair people with you. as fast as you can, because these have a lot of experience and they have made failures before you. So when you have a great idea, or when you believe you have a great idea, usually there's something, but somebody needs to shape the corners so that you make it really ready to tell to your customer. So that makes it about how big we are and when we registered. And since, even though we registered last year, we still make a couple of mistakes. It sounds like we failed forward, I say. The first mistake we did was to believe we can hold our expectations on time. So I had this nice conversation with Dan Birkenstock, the founder of Skybox, and he said, and it seems to be true because we experienced it. They say, whatever you think you can do in time X or time T, be sure you're going to make it double the time. So you're going to be ready only, if you say in 1 month, you're going to be ready in 2 months, because in the meantime, things you didn't expect came out. Your customer called you and you didn't believe it was possible, or you get this government opportunity you want to jump on and you need to fit it within your schedule. So somehow don't promise, don't promise the world to your customer. Try always to take 100% margin. And I know there's mainly engineers in the room, so I know you understand margins. So just do that on schedule as well. And on the success, I'd say the best things we learned is indeed to listen. The best we try to do today, and I hope we're going to continue doing this, is try to listen and not try to enforce our solutions. Sometimes I've been talking to people and say, oh yeah, I have this feature, which is super cool, and then your customer looks at you and say, well, I don't think you understand my business. And so far, early on, we tried to, and we keep trying to listen more, to try to shape eventually our services, very high resolution services, in the best way possible, so that it helps the end user having their application getting better, more revenues or something.
So I just want to touch on the people with grey hair or no hair. How do you choose those people?
You just count the hair, right?
But how do you, because that's an important point, if you're putting together a board or advisors or even mentors, what's your criteria for deciding on that relationship?
Yeah. I'd say the vision first. Any entrepreneur here has a vision. I think the North Star, I like that expression. So that's usually the first thing you say to someone when you explain your story. Say, hey, I want to do this. And then you see the person not believing in it, and you say, well, maybe I can break it into pieces. But if directly the person reacts and say, hey, yeah, I think you're right. Let's see how you can build it from zero, and then you have 1,000 steps, and I understand that. As soon as you have this click with a person, this might be a good candidate. But this might be also good for an employee or a partner, anything. An advisor, I think, comes when they tell you something, and then it's 2 months' time later, then you realize this person was right. And then you say, well, okay, maybe I can call back this person who didn't have any interest giving me this advice. And you can call that person back, and you can propose something. And usually, I'd say from our experience, the people that accept to follow you without any compensation, without any promises, are the best advisors, because they're really your friends even, and they really want you to succeed. So but I'm totally opening this to the others.
So, Rafal, you want to speak a bit about what you're doing and your experiences and what you can share?
Sure. So I actually have a longer talk about this in the evening, guys, with a lot of pictures if you'd like to join, but I will try to summarize it in a few sentences. We are around 30 people right now. Most of those guys are based in Helsinki. The idea of ICEYE was born back in 2012. For 2 years, it was a project within the university. We incorporated in early 2015. And we are at a stage that we have 3 launches scheduled for the next 12 months, starting with October this year. And just to add to what's been said, and I would sign myself under all of these advices. So get yourself an advisory board for sure. I like the part about the time. you will soon realize that whatever you're planning is going to take more time than you thought it will. And I guess what you will also soon realize is that's going to take more money than you thought it will. So be prepared for both. And either one of these sooner or later is going to cause a struggle, and then be prepared for that too.
Okay, thank you. Right, Robbie, let's change it a little bit. You've done your Series A, you've done your Series B, you've got hundreds of people, you've got to scale the business, you've got to get revenue. Now, where do you go when you're at this stage? What are your considerations? How do you build the business going forward? What are the lessons learned and the challenges?
Yeah, there was actually a seed round before the Series A and a Series C. So there's been a lot of investment into our mission, into our company, and today we have about 400 people in the company, with 150 in Europe, like I said, and a bunch in San Francisco, Seattle, Texas, and DC, and Canada. We are making money. We are making recurring revenue. Agriculture is our largest business today, which is a good sector to be into because they actually are technology forward organization. They've been investing in sensors and their combines and other stuff for literally decades. They call it precision ag, and so that industry is a super good one. So, in thinking about building your business and actually getting recurring revenue, is to really try to find a beachhead customer, and that's somebody that's going to validate your product in the market. It's going to be somebody that's a reference customer that will brand you. And so choose your initial customers, kind of like your board of investors and advisors, wisely, because they end up actually branding who you are. And you end up adopting their vernacular and their language. And so we chose that very, very intentionally at Planet, being an Earth observation company where the majority of Earth observation is really, we heard this in Briguette's comments, is really in the Ministry of Defense. And we chose to first go commercial. And we are now selling to governments. But that's after we already validated our core monitoring product offering in the commercial market. Then we're selling the exact same thing to the federal market. So next for Planet is really focusing on, well, we have a lot of satellites in space, and we're catching all of the data right now, commissioning all the spacecraft, distributing them in a long track into one orbital plane. And so this year is really about us releasing this data to the world and getting a lot more developers on top of our platform. So we released actually on Friday, if you go to planet.com/explorer, a public version of some of the features of our browser. You don't have to log in, and you can get a monthly mosaic of the entire world at a coarser resolution for the entire world than at relatively native resolution over the United States. And so our focus is on really building the economic engine of the organization, subscription information feeds on top of our platform, playing with business models around revenue sharing with our application developer program, and trying to understand platform economics around how to make money on top of that, where our users are able to build a viable business, and we are able to as well. Then the economics of Earth observation change. But we're not there yet. We're attempting a number of different things, a number of different trials. But the core thing of what we're doing is still extremely large enterprise sales to very, very large companies and governments around the world to become economically viable. So I guess as back to the idea of recommendation or like lessons learned thus far, and I mentioned this as my third one, I guess, in the previous panel, was around be commercial first. And to put a little bit more nuance on that, I would suggest thinking about where the trends in the industry are going and where the market can go, and build your product to that. But what you sell, don't make it a change in behavior for your users, really go to where the market is today, build a sustainable financial business model on top of that, give yourselves, therefore, the runway to continue to invest in behavior change. And for this industry in Earth observation, behavior change is really getting it fairly automated, abstracting away geospatial information services, and getting toward contextual information feeds to then power new applications to then run at the speed of business.
Great. That's really good advice. Thank you. So do we have any questions from anyone relating to the advice that's been given, about maybe some challenges you have with your work, obviously? Anyone have any questions? No? Nobody has no issues? Nobody's struggling? Everything's tickety-boo? Very good. So I'm going to ask a final question. Earlier on today, there was some talk about focus on verticals. I heard that a lot. Focus on verticals, 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 verticals. I have some experience of working with a multilateral organization where the verticals don't talk to each other. So one vertical built something at several $100 million, didn't apply any geospatial or EO technology, and the project is pretty much doomed. So focus on verticals is good. How do you get that vision across broader marketplace? Robbie, do you want to?
Isn't that what GEO's for, right? It's a convening body. It really helps to kind of promote Earth observation in a variety of other sectors. So it is a challenge, especially in the government community, where you have defense that do certain things, and you have development that do other things, and you have forestry and agriculture. They all kind of buy Earth observation data for their particular purpose. And so that is a challenge. And the current industry today absolutely loves selling the same pixel to the same government, but different organizations, because they can make more money. So this is a real challenge. And I think but we are beginning to see some shifts in that. The World Bank, for instance, they have an organization and what they call a community of practice, where they try to convene together people within different organizations within the World Bank in order to promote collaboration as well as adoption of Earth observation data products and services into the development projects that they do. You have, again, in the development space, the World Bank, for instance, or not the World Bank, the Gates Foundation, they are also recognizing that geospatial data products and services are cross-cutting across poverty, across disaster response, health, and so this is a new capability that is coming to a variety of different industries, and I think the focus should be on going to, again, verticals that are early adopters with technology, and some will be late majority adopters, right? For instance, I think that the insurance sector is probably going to be the largest consumer of derivative products, but that will be years, because by nature they are extremely risk averse. So they want to ensure that the data set is consistent and viable, and that the products actually work and are validated, and they've been around for a long time. So I think it is a challenge. I think that part of what the community can do is convene a lot more in different fora. The intergovernmental community, again, I mean it not tongue-in-cheek, but GEO does play a very important role in breaking down silos within governments in and of itself, or between governments. And then the same thing can happen then within organizations, and again, community practice as an example within the World Bank to do that.
Thank you. Do the others have a perspective on that?
Yeah, I think, I mean, this is not only an industry problem, that's also like a scientific problem coming from a scientific background. I think if you take a look at problems or computational problems that have been solved in biology, for example, like 20 years ago, some this is not a real world example, but some mathematic researchers are just figuring out those problems, or probably more likely the other way around. Abstract mathematics has already figured out algorithms or methods to do stuff that medicine or some other field is struggling with for years. Because they all go to mathematical or medical conferences, they talk to other mathematical professors, researchers, whatever, there's almost no cross-communication. So what you see happening there right now is that different FOA are also being funded and set in place for cross-science communication, cross-science projects, or just within one university you already have most of the different scientific departments not communicating to each other. So starting more like a communication first, so you learn about the different challenges and problems that are solved in different industries or sciences or you name it, governmental organizations. That's a global problem, I think, is that we all work vertically but do not communicate horizontally. So I think this advice of focusing on a vertical market with your product, with your development, with your research does make sense because you need that focus, but it doesn't necessarily mean to neglect the communication on a horizontal axis. So I think this entire movement of more communication across industries in science, politics, everything is probably the most promising for future innovation in that sectors.
Great, good insight. Thank you.
I'll try to bring another view on this, that maybe early on to build on what you said is, let's say at VEOWARE space, I'm quite happy about this. Is, for instance, my co-founder, and I'm pretty proud, has never worked in the space sector, and he's the one in charge of the technical stuff. He worked in plastic foams. He worked in the glass industry. He worked in the let's say plane aviation, basically the motor industry. So that's why sometimes when I say, "Hey, Dad, that's how we do," and you say, "Well, probably we can use this in what I learned in the glass industry," or you say, "Well, your idea is just stupid," and then I have to shut up. But when we already have a team that itself comes from different verticals, basically from the beginning, you have that in place. You have that in place, and obviously your team cannot cover all the verticals, but you can yourself plan for it. So if you say, look, Earth observation is applicable to this vertical, this vertical, this vertical, maybe early on you should have somewhere in your team people from there. And maybe they don't know anything about space, but that's good. That's good. So I would definitely recommend having a multidisciplinary team, multi-vertical team.
Rafal?
I will try to add. It's quite a difficult subject, I guess, because right now on our side we are struggling to convince verticals to move into purchasing a lot of Earth observation data, to actually use it within the vertical, whereas now we are trying to figure out how even to make multiple verticals that are already purchasing Earth observation data talk to each other. And definitely some experience that we can share from industry like maritime or oil and gas is that it actually takes a lot of time and effort to convince people to change their habits and to start using Earth observation data that's a little bit different than what they were using before. So even nowadays, when we try to build an offering for our customers, we're actually making it closer in terms of the way it's being structured to what they are used to, because they are actually reluctant on purchasing something that would seem even a little bit more efficient from their perspective. But where I want to go with this, I feel like potentially the delivery mechanism is the way that would allow these verticals to communicate with each other. If the data would actually be available for all of them from the same platform, they might notice that they're actually purchasing pixels from the same place. Whereas right now, when we are signing contracts, even within the same government, we're usually delivering to a different location for each of these, I wouldn't say verticals even, it's probably the same vertical. For each of these customers within the same vertical, within the same government, we are delivering data to the different place. So the fact that if we would actually be able to combine all this data to a single platform, potentially that would make verticals more aware of the fact that they are all using the same data and they are purchasing them multiple times. Whereas The question is, of course, whether we want to do that. I guess yes, in the future. At first, it makes sense for us to sell the same pixel several times. But as we all believe over here, I guess the true value of the Earth observation will be in the derived products, and I actually agree with the insurance industry. We've talked with them a little bit, and this is going to take a lot of effort for them to get convinced. And honestly, my hope is that Planet will take this effort from us.
So,
Can I quickly
very quickly, yeah.
Yeah, so we've talked about this advisory board idea, and one thing that I've seen work really well also with the consultancy is that take an advisory board that's different industries, different experiences, different sectors. So they're not necessarily operationally involved in your business, but they'll give you different angles and connections to different people. So maybe like look for advisors and or consultants in different scientific, industrial, whatever areas that are not necessarily and really, really remotely connected to what you're actually trying to solve.
Thank you. So in 30 seconds, max 30 seconds each, it can be a desire or a pitch. What's the next thing for Earth observations? Robbie? A desire or a pitch. What do you want to see, or what are you selling? You've got 30 seconds.
Well, since you said a pitch, we have about 20 openings for software development here in Berlin. Timo in the back can raise his hand. There he is. He's our director of software eng. I'm super excited for the downstream ecosystem. I really want people to experiment and to play with some of these activities. And really, I think it's going to universities and to software development organizations, not people in geospatial. So that is my pitch, is for us to go to where the technologists are.
Thank you. Pascal?
So I'm in a lot of conversations around next big things, and I think looking into the connection between cybersecurity, which is also one thing that will more and more valuable data will come up in the Earth observation sector, artificial intelligence, and the combination of both in connection with any data set. These will be the skills that are probably most valuable for the workforce in the future. So focus on that.
Julien?
Yeah, so at VEOWARE Space, we have this vision that Earth observation should be for everyone every day, and for that I wish there's no pictures anymore. I wish, like the GPS, when people get an application, they don't actually realize there are satellites behind it, not even pictures, just numbers and graphs.
Thank you. Rafal?
I share this vision. I think before we get there, what I'm excited to see is actually a few data sets that are indeed covering the globe every day, both in SAR, optical, and potentially in hyperspectral. And since Robbie started with it, I will mention that we've got openings too. So please check on our website and please apply.
Thank you very much. Ladies and gentlemen, please thank you to the panelists.